Hi everyone! Last time we defined the population mean, the population variance, and the standard deviation. So today we're going to continue to do some examples. So example 4. If the probability x equals 0 is 1/2, the probability x equals 1 is 1/4, and the probability x equals -1 is 1/4. Find the mean, variance, and standard deviation. So everybody please pause the video here and try to work on this example. After you finish, you can continue to play the video and check your work. Alright, have you finished? Let's see. What is the mean? Okay, mean is we use the x value times the probability. So 0 times 1/2 plus 1 times 1/4 plus -1 times 1/4. What happened? Well, 0 times whatever is 0. But do you see those two terms are the same except the sign? So they actually cancel out. And we get the mean is 0. Okay? And then the second variance. Okay, variance. We use the x value minus the mean squared times the probability. And then 1 minus the mean squared times the probability. And then -1 minus the mean squared times the probability. And what is that? Well, this is 0. 0 times whatever is 0. And then this is 1. So 1 times 1/4 is 1/4. And then look at this. -1 squared become 1. So 1 times 1/4 is 1/4. So 1/4 plus 1/4 is 1/2. Do you see now? We get the variance is not 0 because they can't cancel out. You see, because of the square, -1 squared is +1, so they're not canceling out. Okay. And what is the standard deviation? The standard deviation is square root of the variance. So this is 1 over square root of 2. So far, so good, everyone? Okay, so this is part A. And how about part B? Okay, have you finished part B? Alright, let's check your work. So E of y is the y value 0 times the probability plus the y value times the probability plus the y value times the probability. Now you see what happened. This guy is 0, and then those two terms, they're the same. They have the same magnitude but different signs, so they cancel out. So we also get the mean is 0. But how about the variance? Variance, we have 0 minus the mean squared times the probability, and then 10 minus the mean squared times the probability, and then the y value minus the mean squared times the probability. Alright, so this guy is 0. And then, okay, 10 squared is 100. So 100 over 4. And then this is -10 squared is also 100. Another 100 plus 4. So 100 over 4 is 25. 25 plus 25 is 50. So the standard deviation of y is square root of 50. 50 is like 25 times 2. Square root of 25 is 5. So 5 and square root of 2. Okay, now you can see part A and part B, the mean are the same, but the variance are different. So let me draw pictures of them, then you can see. The first one, okay, 0 is 0. Oh, sorry. Is 0. 1/2. Let's say this is 1/2. So this is the probability bar charts. So we have 1/2 right here. At 1, we have 1/4. At -1, we also have 1/4. Oops. Let me draw better. Look at this picture. Because this picture is symmetric about the origin, right? So that's why the mean is 0. The mean is like the center of the probability mass, right? So the center is at 0. Okay, and the variance is about like how the fluctuation of the size of the fluctuation of the data. So whether the data are close to each other or spread out. Okay, and for the part B, the picture is like 0. We have the probability is 1/2. But at 10, the probability is 1/4. And minus 10, the probability is also 1/4. Now you can see the center of the mass is also at the origin, so the mean is 0. But now you can see because the data are far away from each other, so that's why the variance is gonna be bigger than the variance of part A. Okay, so if the data are close to each other, the variance is small. And if the data are spread out far away from each other, then the variance is big. Okay? Alright. I hope this example can let you know like what is the mean represent, what is the variance and standard deviation represent. Okay, let's continue. That variance equals the second moment minus the mean square. So this guy is the second moment minus the mean square. Okay, this is very important formula, and the proof is actually very simple. Okay, just use some algebra, so I'm gonna prove it with you. Okay, alright, so variance equals sum of x in the range of the random variable x, and then we have x minus mu square, and the probability x equals x. Okay, alright, now what we do is let's FOIL this factor. Okay, so we have, well, this is x squared minus 2x mu plus mu squared, right? Okay, this is how we FOIL it. And then next, what happened? We can distribute it, right? So this is sum of x, distribute x squared times the probability minus sum of x 2x mu times the probability plus sum of mu squared p of x equals x. So we just distribute it, and so far so good, everyone. Okay, what is this guy? Wow, this guy is the second moment, right? And how about this guy? Well, because 2 and mu are constant, we can pull it outside of the sum, and then we just have sum of x times p of x equals x. And now here, mu squared is a constant, so we can pull it outside. We just have sum of x of p x equals x. And what is this guy? Remember the sum of x times the probability of x. This is exactly the mean. It's just mu. And then what is the sum of other probability? Equals 1, right? Because this is a probability mass function, so when we add up all the probability, it equals 1. So that's why we just have the second moment minus 2 times mu and times another mu, so mu squared, plus mu squared times 1. And so the answer is the second moment minus mu squared. So this is the proof. and we just use algebra. Right, everyone? So far, so good? So this formula is very important. Okay. Next, lemma. If x has the binomial distribution, then the mean equals n times p, and the variance equals n times p times 1 minus p. And how we prove it? We compute the second moment, and then we use the second moment minus the mean square. So that's why that formula is very important. Okay, we can use it to prove the formula for the variance of the binomial distribution. Okay, and if x has a geometric distribution, then the mean is 1 over p, and the variance is 1 minus p over p squared. And we also compute the second moment and use the second moment minus the mean square. Okay? And if x has the hypergeometric distribution, then the mean is n times m over n, and the variance is n times m over n, and then 1 minus m over n times this guy. This guy is actually called the finite population correction factor. Okay, and remember we said the binomial distribution and the hypergeometric distribution. The binomial is like sampling with replacement. The hypergeometric distribution is like sampling without replacement. So we can use, if the population size is so big, we can use the binomial distribution to approximate the hypergeometric distribution. And remember, for the binomial distribution, and the mean is n times p. So if you want to use the approximation, n equals m over n. So that's why n times p becomes n times n over n. So that's why it matches with the mean. And the variance of the binomial distribution is what? np times 1 minus p. See? Here. np times 1 minus p. So np times 1 minus p. So this is like n times p is m over n. 1 minus p is 1 minus n over n. And then you realize, well, this guy corresponds to this. But then, oops, sorry. But we have an extra factor is n minus n over n minus 1. So this is the finite population correction factor. Okay, so that's why they're not exactly the same. They're slightly different. And when the population size is getting bigger, you realize this guy goes to 1. Okay, because small n is like some fixed number, 1 is just some fixed number. If the capital N goes to infinity, this guy just goes to 1. So that's why they kind of match the results. Okay? And this is the proof. We also compute the second moment first and then use the second moment minus the mean square. Okay? Alright, conclusion. So we have learned the 3 discrete distributions, and then here are the formula for the mean and the variance. So you don't need to memorize the formula, so this table will be provided in the exam. Okay, so let's continue. Fact: if x is a random variable and a, b are real numbers, then the mean of ax plus b equals a times mean of x plus b. And the variance of ax plus b equals a squared times variance of x. Okay, what does that mean? Well, if you multiply a data by a, what does that mean? So let's say this is x. So let's say it's 0 is 1/2. This is at -1 and 1 at 1/4. Okay, this is x. Then 10 times x, what is that? Well, this is like our part B, right? The 0 times x, and then -1 times 10 is -10, and then 1 times 10 is 10. So 10x is like we multiply the x values by a factor of 10. Okay. Now, what is x plus 1? So, what is x plus a number 1? Okay, it means all the x values now we plus 1. So 0 become 1. And then the 1 become 2. The -1 becomes 0. So we shift the data to the right 1 unit. Alright. So the first thing tells us that the mean of the new random variable equals a times the mean of x plus b. And then the variance of the second random variable is a squared times the variance of x. And you can see here there's no b in the formula of the variance, because the variance just measure like how close the data is. If you move the whole set of data to the right or to the left, it wouldn't change the that's my son, sorry. Okay, so that's why the variance does not depend on whether we shift the whole data set to the right or to the left. Okay, all right. Yeah, so that's why we mark adding b just shift the whole probability distribution. No effect on the variance. Okay, so let's prove this formula. Okay, so first of all, e of ax plus b. So that is sum of x, and then ax plus b, and then the probability x equals x. Alright, so we can distribute, right? So it's sum of ax times p of x equals b plus sum of x b times p of x equals x. And then now, because a is a constant, we can move the a outside of the sum. B is a constant, we can move it outside of the sum. Now you can see this is just the mean of x, and this is just 1, right? When we add up all the probability, it just becomes 1. Okay, so now we have shown that the mean of ax plus b equals a times mean of x plus b. Next, to compute the variance, we always compute the second moment and then use it to subtract the mean square. So what is the second moment? Well, okay, so ax plus b squared p of x equals x. Well, you see this quadratic factor? Let's FOIL it. So we get a squared x squared plus 2abx plus b squared. And then the probability. Okay, now let's distribute it. So the proof is very similar. We just play with the algebra, right? Distribute it. And okay, so we distribute it. Well, the a squared, because it's constant, we can move it outside of the sum. Then we just have x squared and then the probability. And then the 2ab are constant. We can move it outside of the sum. And then what's left? We just have x and the probability of x. And the b squared is constant. We can move it outside of the sum. Then we just get the probability. Now what happened? This is the second moment of x, right? And then this is the mean of x. And this is 1. Okay, so then this is what we get. Okay, finally, variance of ax plus b equals the second moment minus the mean square. Okay? Alright. What is the second moment? Second moment is a squared, e of x squared plus 2ab mu plus b squared minus the mean square. Well, the mean is this guy. So e of x is just mu. A mu plus b squared. Okay, now let's see. This is a squared times the second moment plus 2ab mu plus b squared. And what is this? Wow. Okay, it's a squared mu squared plus 2ab mu plus b squared. Right? Okay, now let's see. 2ab mu cancel, b squared cancel, and then you see this guy minus this guy, and they have a factor, common factor a squared. So we have a squared, and then we have the second moment of x minus the mean square. Ooh, that is exactly the variance of x. So now we have shown the variance of ax plus b equals a squared times variance of x. Okay, now we have proved the formula. Let's use that formula to compute this example. Okay, so have you finished? Let's see. If z has the binomial distribution, okay, then the mean of z is n times p. N is 10, p is 1/5. So this is 2, right? The variance of z is n times p times 1 minus p. N times p is 2. 1 minus p, 1 minus p 1/5. So this is 4/5. You get 8/5. Right? Okay, now what is the mean of 3z plus 2? By our formula is 3 times e of z plus 2. E of z is 2, so 3 times 2 is 6. 6 plus 2 is 8. The variance of 3z plus 2 is 3 squared times variance of z. 3 squared is 9. Variance of z is 8/5. So we get 72/5. So far, so good? So we just use the formula that we just proved, and then just simply apply the formula here, and then we can get the answer. So this is session 4.4. If you have any questions, feel free to ask me. Have a nice day. Bye.